Under this video, I would like to implement a mechanism that will allow us to extract random words from a database instead of using the default game word each and every time. So as a first step, we need to go under pom.xml, and over here we need to add some specific dependencies. So the first dependency will have the group ID org spring framework .put, and for the artifact ID spring boot starter Data JPA. And now the second dependency will have the group ID MySQL, and for the artifact ID we need to set up the MySQL connector Java. So since we have this dependency in place, we will need to go under com Hangman game model package and create a simple class, and let's call it word. So this class will act as a JPA entity and will allow us to interact with the database. So let's annotate it with entity. Be sure to use the Java persistence entity package, and let's also add a table name as being the words. We'll now need to set up a specific variable that will act as a primary key for our words table. So we annotated it with the ID, and the generated value will use generation type strategy as the identity. So let's do this. Now let's add a private long ID variable. And I would like to also set up a private string value. But first let's annotate it with column length 16 and unique true. We will now add a public constructor, a default constructor that is required for Gpa entities, and let's use the IDE to generate the getters and setters for our value field. Okay, our next step is to create a corresponding word repository. So this is related to our Spring Data JPA. So this needs to be annotated with the repository stereotype. And of course, it should extend the JPA repository. And as parameters, we need to set up the model class and the type of the primary key, in our case long, and for the model class, of course, the word class. The next step will be to create a service for our interaction with the business logic and our GPA entity. So let's call this service word service, and let's set it up under com Hangman game service package. So let's change it to an interface, and we will define two methods. One that will store a list of words into the database when the application will run first time, and another method is to extract a random word from the database. So we'll need a concrete class implementation to actually implement these methods. So I created word service IMPL and annotated with service stereotype, and this class implements the word service interface. Let's also add a unimplemented method so far, and let's also inject the word repository. And for the list of words, I already prepared for you a list of 1000 words that will be stored to the database, so you just can copy paste this without writing them down. You see there are many words that you can play with, and we need the mechanisms to actually store this list of words. So under save data in DB method, we'll first check if the word repository count method returns 0. This means that we don't have any words stored so far in the database. We'll split the word list into an array separated by comma, of course. And we'll iterate over this words array and save each word into the database using the word repository save method. So for this, let's create a simple constructor that receives the value as parameter. So this value equals value, and this should fix our problem. We'll store directly a word into the MySQL relational database. Let's move now to the getRandomWord method, and for this, let's go to the word repository and set up a specific method. So this will return a word, and let's call it find random word, and we will use the query specific annotation and do a select from let's call our database Hangman, since the game is Hangman, and invoke the Hangman words, order by rand, limit 1, and native query should be set to true. So this will extract a random word from our Hangman database that we'll configure later, and from the words table that we configured earlier in the word corresponding model class. So going back to the word service IMPL, let's use the newly created method from the word repository. So word repository, find random word, and let's retrieve the string value using the getValue method. Now, since we have these two methods in place, we'll need a way to actually invoke them. So for the first method, let's go to the game application, and over here, when the application will start, We will first inject the corresponding service using the auto-wire annotation, and of course using the post-construct method. Spring will automatically invoke this method, and at this stage let's do a save data in DB call from the word service. In this way all words will be stored into the database. Now we need a way to invoke this getRandomWord method, and if you recall, on the word panel we set by default that game as being the generated word, and we need to change this. So let's auto-wire the word service instance, and instead of using the game text over here, let's use the word service getRandomWord method. So each and every time we'll generate this panel, a new word will be extracted from the database. Now an important step is to set specific properties under our application properties file, so that Spring will be able to communicate with the MySQL database. So we'll set the Spring Data Source Driver class name as the class name that corresponds to the MySQL instance. We need to set the Spring Data Source URL, so this URL matches the MySQL instance that we set up locally and connects to a Hangman database that we'll create. For the Spring Data Source username, we have the MySQL instance username set to root and the password set to password. Of course, this depends on your MySQL instance. We will show the SQLs that are generated in the logs, and we will use the DDL auto update in terms of possible changes that we will do to the word model class to be automatically stored under the MySQL corresponding instance. Now let's set the MySQL dialect. So org hibernate dialect, and let's store the file MySQL SQL 57 dialect. Now I went to my MySQL instance, and all you need to do is create a simple database called Hangman, one time only. And let's start the application. And let's look at the logs. You see that all words are being inserted. This process happens only one time, and you see that already we have a random word extracted from the database in the graphical user interface. We can also review the fact that all words have been inserted into the database using a count from the words table, and you see 1000 words. And now the game works much smoother in terms of being able to generate random words each and every time. You see long words, short words, and so on.